do this last year. Well, I take that back. You've done this. You just didn't, I didn't show you the graph of it. We're going to graph the inverse sine of x, because I don't think you've ever seen it before. You know what it is. What do you do when you take an inverse of something? What does it bring you? Okay, yes. But the inverse sine of 1/2, what am I actually asking you for? The what? The angle, the degree, the radian, okay? That's what I'm asking, correct? When you say inverse sine of 1/2, I'm saying, okay, what's the angle that got you 1/2 at sine? Or if I say cosine, what's the inverse cosine of, square root 3/2? I'm asking you, what's the angle that got you square root of 3/2? All right. Now, but we've never actually looked at the graph, which I want to, hopefully if you can see it here. There we go. Weird. I got to turn it off for a second. So there it is, inverse sine of x. I'm going to hit zoom 6 just so you can see what it's literally that big. Let's zoom in, shall we? Okay. Actually, let's put on let's change our window. So my x min, I'm going to actually make -1. My x max, I'm going to make 1. I'll go by a scale of 1. My y min is going to be -pi, and my y max is going to be pi. Whoops. And I'm going to go by a scale of pi/2s. And you'll see why. There we go. Come on, baby. There she goes. Okay. It is literally this big. That's all it is. And what that means is when you go to answer it, your answers are in a restricted zone. Okay. And I didn't do that last year with you. We would actually give 2 answers for most of these. Okay. Because all students take calculus. Cosine 1/2. Oh, it could be right in this angle, right? Could be in quadrant 1. Or else, where else could it be? Cosine 1/2, where else? All students take calculus. Quadrant 4, right? So we would have to we always gave me 2 answers. Well, now there is restrictions within the outputs of the inverse. Okay, so I need you to write down those restrictions. Y is equal to the inverse sine of x if and only if sine of y equals x and -pi/2 is less than y is less than pi/2. This is your restricted output. What does that mean, Miss Aceta? That means all of your answers for inverse sine are located between, let's just do it in degrees, since I think sometimes you all with radians, you're like, I don't get radians. So let me just do it with degrees. All of your answers have to be between -90 and 90 degrees, which graphically means, wouldn't you agree, here's -90, here's 90. All of your answers have to be in quadrant 1 or 4. Your answers, your angles have to be in quadrant 1 or 4. Okay? Weird, isn't it? Yes. And it's all because of the way the graph looks. We didn't do that last year because I just was introducing you to just how to take an inverse of an angle to find the angle. Just so you know, cosecant, which you know is the reciprocal to good old sine, it's the same restricted output except that y also can't be 0. So we might as well just put it here. There, it's the same one except y can't be 0. All right, what about cosine? I'm not going to graph it for you, but you can do the same graph if you want to. But cosine has restricted outputs. So if cosine y equals x and 0 is less than y is less than pi. So there's your restricted output. What does that mean? Where are all your answers located? What quadrants? From 0 to pi. 1 and 2. That's all you can give me answers in, 1 and 2. Secant, by the way, is the same restricted output, except the also stipulation is secant can't be 90 degrees, can't be pi over 2. There's nothing there. And last but not least, tan and cotangent. And cotangent is its own, actually. So tangent is actually similar to sine, where your outputs would be between 90 and negative 90. So that, again, would be quadrant 1 and 4. And cotangent, your outputs would have to be between 0 and pi, which would be quadrant 1 and 2. Okay, now, I'll be honest with you. I'm just introducing this to you. It's not that big. On homework tonight, even the problems I'm about to do with you are harder than the homework problems tonight. You'll see. Like, you'll be like, oh, okay, thanks. What's the inverse sine of 1/2? Oh, okay, I got this, you know. You just, it's easy, like 30 degrees, 60 degrees. It's going to be much easier. But I'm going to give you some challenging problems now just so you can see and understand. And then you'll do the homework and be like, that wasn't hard. So let's evaluate 3 problems and we're done. Yep. So most of your problems are going to be easy like this, okay? Where I'm asking you to, again, what am I asking you for? I'm asking you, what's the angle that's going to give me a negative y value of root 3 over 2 on your unit circle? So you go to your unit circle right now, if you have one out, and look to see where is all the times that you have sine being negative root 3 over 2. Where and where? 240 and where else? 300. Okay, so 4 pi over 3, is that right? And 5 pi over 3? Okay. So you're like, okay, well, which answer do I choose, Mrs. Setta? Well, again, our restricted output has to be between negative 90 and 90. And the answers you gave me were 240 and 300. Yes? So how do I make that into this restricted, again, I'm going to degrees. Let's just go to degrees. How do I make it go into there? Well, first of all, which one would I choose? I kind of gave you a hint here. You either choose it in quadrant 1 or quadrant 4. So guess which one we're going to choose? The 5 pi over 3, right? But we're not going to give that as an answer. However, on a quiz or test, I will completely accept that as an answer because I know exactly what you're talking about. All right, but how do we make this go in here? How can I make a 300 go in between negative 90 and 90? Do you remember? Coterminal. That's exactly it. Just subtract 360. What's 300 minus 360 make? Negative 60 degrees. And let me show you this on the calculator, just so you can see, because this is what the calculator does. It actually does the domain restriction for you. For those of you who, it wasn't on the ACT though, I'm surprised. But if you go to mode, I actually have to, I'm going to change the mode to degree just so you can work with degrees so you're not freaking out. But if I go inverse sine of negative second square root of 3 divided by 2, whoops. Can you see that? There we go. And hit enter, boom. That's what we did, okay? And honestly, like I said, this one's actually harder than the one in the book. They actually made everything work out nicely for you. So I don't understand why we're even, like, why I have to teach this to not give you problems like it, but whatever. All right, so let's do these last two here. Start in the middle. What did they not do right here, by the way? 1 over square root of 3. Yeah, let's rationalize. So this would be square root of 3. So let's take the inverse tan of negative square root of 3 over 3. Now that's not on your unit circle. Remember, that's on the chart that I did. So where is the chart for tan. Where is tan at root 3 over 3? 60s, right? But I need it to be a negative. So again, according to all students take calculus, I need a 60 degree in here and a 60 degree over here. Those are the two positions where tangent would be negative. What's the 60 degree up in here? 120? And what's the 60 here?
300.
Okay, so which one am I going to look at? I want to look at 1 or 4. Okay, so I take the tan then. So I'm going to look at 300 and I'm going to take the tan of it. What's the tan of 300? What's the tan at 300? Anybody?
Negative square root 3.
Oh, look at what you had done. You took the tan of an inverse tan. What happens when you take those square root and square it? What happens to that? Doesn't it pop back out? What happens when, right, they're inverses of each other. They're inverse functions. These are inverses of each other. I got that as my answer. Did you see that? Maybe you didn't. That's why I took you the long way, because I want you to notice that could happen. Okay? So my answer is same thing, negative root 3 over 3. However, look at number 3. What do you think is going to happen at number 3? What do you think your answer is going to be? The inverse cosine of cosine. What do you want it to be right now? Just go ahead and tell me. What do you think? 5 pi over 4. Don't you want it to be 5 pi over 4? Doesn't that, you Mrs. Seta, they're inverses, it should be 5 pi over 4. I agree with you. I agree with you. But the problem is, according to the inverse trig functions that I just was talking to you about, 5 pi over 4 won't fit. 5 pi over 4 is not between 0 and pi. Remember, pi is 4 pi over 4, so I have to be between 0 and 4 pi over 4. Okay? So what could we do? Well, I could somehow make it fit to be in quadrant 1 or quadrant 2. So you just work it out to be in quadrant 1 or quadrant 2. So here's what I'm saying, okay? So let's do this right here. Let's just take the cosine of 5 pi over 4. What is it?
Negative root 2 over 2.
Negative root 2 over 2? Okay, so I am, all students take calculus. I am negative root 2 over 2 in here, correct? And here? Agreed? Which one of those do I want to look at? Do I want to look at this one? No. Why don't I want to look at this one? Because I already kind of gave you a little cheat sheet here. I only want to look at quadrant 1 and 2 for cosine, inverse cosine. So I'm going to look at this one, which happens to be, is it, so this was negative root 2 over 2. But what's its angle?
135.
135, which is 3 pi over 4. So the answer is actually 3 pi over 4 and not the 5 pi over 4. Okay? And 3 pi over 4 is between 0 and pi. That's why. Now, you could have put that in your calculator. This is much more complicated. Like I said, this is actually harder than the way the homework is going to be. And just to show you, the homework is much simpler. It's more like, take the cosine of a half, inverse cosine of a half. Take the inverse cosine of 1. I think there's one that might be a little bit trickier, but that's it. That's your answer. That's your homework for tonight. Or the whatever. So do 207 to 215. Which is a whopping 8 problems. It should go quicker than what we even just did. When you're done, do the study guide for the quiz, which is up there. The key is online, except for the key is wrong on 2 parts. And that's it, kids. This is a nice day. Study guide would be due next class. No, I mean,